Hey everyone, this is going to be a couple quick examples of how to simplify trigonometric expressions using trig identities. So for this first one here, actually for all of these, remember that there's a lot of different ways to simplify trig expressions. So just because I did it one way doesn't mean that another way doesn't work. A lot of this is just trial and error. And after a while, you kind of start to get good at recognizing what will typically work and what won't work. So these just kind of take practice. So here we go. For this one, the first thing that I notice here is that these both have a cosine squared in the term. So what I'm tempted to do here is factor out the cosine squared. So I'm going to go ahead and try that. So if I factor a cosine squared out of both of these, we get cosine squared and then times the quantity of sine squared minus 1. Okay, so now we've got this sine squared minus 1, and this is starting to make me think about Pythagorean identities. And so remember, the big Pythagorean identity that we should all know is sine squared plus cosine squared equals 1. So that's the main important one, right? Because you can find the others from this by either dividing through by sine squared or dividing through by cosine squared. So what I would do here is figure out how can I manipulate this to get it to look like this. Well, I need a sine squared minus 1, so I would subtract 1 over here and get sine squared minus 1 plus cosine squared equals 0. And then I would subtract cosine squared from both sides to get sine squared minus 1 equals, and you guys can't see that, equals negative cosine squared. So then I can take this sine squared minus 1 right here and replace it with negative cosine squared. So now we get cosine squared times negative cosine squared, which is negative cosine to the 4th. All right, so there we go. That's our answer to this one. This is what sine squared cosine squared minus cosine squared simplifies to. So that's one way that we can do that problem. All right, for this next one, this one's going to deal a little bit more with the reciprocal identities and quotient identities and stuff like that, because the first thing I notice when I look at this one is that, one, there's no sine and cosine anywhere, and two, there's also no nothing squared or anything like that that would immediately have an indication that we should be using Pythagorean identities and things like that. So this one, the thing that jumps out at me right away is that we're dealing with cotangent and tangent, and both of these can be written in terms of sine and cosine. So if we remember, cotangent is cosine over sine, and tangent is sine over cosine. Okay, so now what we want to do is, since we're dividing fractions here, I want to multiply by the reciprocal of this one. So I'm going to take this and rewrite it as cosine over sine times, if I flip this, it's also cosine over sine. And now I can just multiply straight across. Wow, I write slanted. Okay, so we end up with, on the top, cosine squared of x. On the bottom, sine times sine is sine squared of x. And so then we go back to our quotient identities here. And remembering that cotangent is cosine over sine, so cotangent squared would be cosine squared over sine squared. So this thing is actually cotangent squared. And that would be our final simplified answer. We got it down to one term, so we're good to go. Most things will simplify to one term, some things won't. So there's another problem using our quotient identities instead of Pythagorean identities here. Hopefully this was helpful. If you have any questions about anything, feel free to comment or send me an email. Have a good one.